Hello everyone. So today's question is leaders in an array, and the difficulty level is again easy. Fine. So given an array of positive integers, your task is to find the leaders in the array. Now what does that leader mean? An element of array is leader if it is greater than or equal to all the elements to its right side. Let's like this element is the greatest amongst all these array elements, or this 5 is greater than all the elements present at the right at this number. Note that all the last element will always be the leaders of the element, so no matter what, if this sequence is decreasing, then one element will always be the answer, which is the last element. The last element will always include in the output. You can, as you can see, 2 0 in this, okay, and 3. What are the constraints? N is less than 10 to the power 7 and A of I is less than 10 to the power 7 as well. So let's have a look at the example. Test case is 3, number of queries, this means number of queries is 3. The size of the first query is this, and the size of array given is 6. The elements are 16, 17, 4, 3, 5, 2. Fine, so the answer is 17, 5 and 2. How? 16, is it the greatest amongst all the elements present at the right? No, it's not. 17, yes, it is greater than all the elements. 4, it's not. 3 is not. 5 is yes, greater than only element present at the right, which is 2. And 2 is always included in the answer, which is the last element. So now there is no constraint to this question, but we can see, no expected time complexity or space complexity, so we can use extra space, and we have to solve in less than O of n log n time, as you can see from the constraints only, because if you exceed 10 to the power 9 operations, then it will throw out time limit exceeded. Fine. So always try to solve a question in less than 10 to the power 9 time complexity. Fine. So let's have a look at the solution. This is an input of test cases, and which is the number of queries, input of the size of the array, input of the elements of the array. Now we maintain a boolean array. Boolean means only which contains 0 and 1, which is true and false. True means 1 and false means 0. And current max. Max means the element I am standing at is the max. Till then the maximum element till then is current max. Fine. Now we start iterating the array from the back. Why? Because because let's see, if we iterate from here, no, n minus 1, okay, from here it's n minus 1 actually, and that means this index. Then we keep on updating the value of maximum element present. If the current index I'm standing at, let's suppose I'm iterating this array, and I am at the iteration of n minus 3. Let's suppose I is equal to n minus 3, and the element is 4. Now if my current max is less than 4, my current max would be amongst these 3. If they would be less than 4, then this 4 is included in the answer, otherwise it's not. Now the element 4 is not less than 5, which is the maximum of these 3, so that this will not include in the answer, which is why we are maintaining the count array. Now if A of I is greater than current max is 0 now, then current max is equal to max of current max and A of I, 0 and 2, max of 0 and 2 for the first iteration. Now if this situation occurs, then the ith element will be included in the answer, so count of I becomes 1. Count of I becomes true if this situation occurs, and then after that we will traverse the count of I, and if count of I is 1, then we will output the array index, element present at that array index. Fine. Now if this situation occurs, count of I is 1, otherwise count of I is 0. Now if we neglected this step, it would have made no difference, okay, because we are already initializing this array from 0 with 0. This means initialization of an array with 0. If we remove this array could contain any values, any garbage values or any values 0 and 1, because this is a boolean array. Then it would have contained only 0 and 1 values randomly. Now this becomes a 0 index of size n only. Fine. Another approach would be, if we don't want to use extra space, then simply maintain a current max, and if a of I is greater than current max, then current max is updated and a of I is also updated. No, a of I would not have been updated. Only here we would have done a of I is equal to current max. This would have been a solution. Fine. And we simply printed the array. What does that mean? This mean like current max is 2. Fine. And we are at this element, and this a of I is 5 right now, and we don't change this element because this is already the maximum amongst all these elements, which are 5 and 2. Now if we talk about this 3, when we come to I is equal to m minus 3, so this is not true. 3 is not greater than 5, which is 5 is current max. So else condition states a of I becomes current max, which is 3 becomes 5. Fine. So we would have no, wait, just a minute. No, sorry, I was wrong. So okay, so this is mandatory step. We have to maintain a count variable, because the repetition would be present if we would have simply placed the array elements in the array elements. So the first approach was correct, which is this code. Fine. Thank you.